Hello everyone, I'm Sonam Pankaj and today we will be looking into time series forecasting on univariate data sets of confirmed cases in coronavirus. A little bit introduction about me. So I'm Sonam Pankaj working as a software lead in one of the startups incubated at IIT Madras. I also served as an ex-visiting faculty at PES University for robotics and computer vision. I'm also a tech speaker for machine learning, and this is my first PyData Global talk, and I'm so excited about it. So the content that we will be talking about today is first exponential growth in epidemic. It's intuitively difficult for human mind to understand exponential growth. So we will just take a look into it. History of pandemics. So we all know that pandemics are not new, and we will look into the previous pandemics that and outbreaks in the history. Flattening the curve, why social distancing was important, why it was important to wear a mask and keep a control on the spread of the virus. Metrics of prediction. So we are using various algorithms for prediction and forecasting, and to measure the accuracy, we will be using RMSE, which will be the metrics of prediction. Understanding differences between prediction and forecasting. So often my friends gets confused between what is the difference between prediction and forecasting. We will be looking at some basic algorithms like naive, moving average. Then we will get into machine learning algorithm. But before we get into machine learning algorithm, you'll have to understand how to do the train and valid split, because it's very important to split your data set into training and validation to measure the accuracy. The machine learning algorithms we will be following is linear regression, support vector machine, RNN, the recurrent neural network, and LSTM. The other two libraries available for forecasting are Prophet and ARIMA, and then we will be comparing the results and get into multivariate models. Now, there's a case. Intuitively explain if there's one water lily and it doubles its population every day, how long it will take to reach about 1,000 lily plant for that one water lily. Think exponentially. So here your intuition maybe according to intuition it may take 1 week or maybe 1 month, 2 weeks. So the answer is, when we see the exponential growth, the answer is 10 days. It's going to take 10 days for that one lily plant to go to a population of 1,000. So as I told you, pandemics haven't been new. There have been a lot of pandemic cases in the history, but the global coronavirus death toll on the 30th of September has reached more than 1 million, and there has been 33.6 million cases that have been confirmed, and during the bubonic plague, 200 million deaths were there. Smallpox was also considered as a pandemic before its vaccine was discovered. So, and Spanish flu killed about 50 million people. So we can say there have been pandemics continuously coming in the human history. So why flattening the curve is important? Because if we let the disease, one of the most important factor of coronavirus was the rate by which it was spreading. So the rate is almost R0, that is reproductive rate, is almost 2. So if we allow it to expand at its natural way, it will reach this exponential graph. It will reach its it will go on the red red path. So we do not want that, because it will become very difficult to control that. It will be very difficult for the medical facilities to provide the medical facilities required for that population. So we basically have to bring down the course of the curve into the logistic curve, and that it doesn't surpass the medical facilities that we have now available. Now we will talk about the metrics of performance. So on what basis we will decide which algorithm is performing well? So there could be many metrics. They are called error first, which is like forecast minus actual. Then you can use mean square error, absolute error, each having its own formula. We are going to use RMSE. RMSE, or root mean square, is a quadratic scoring rule that also measures the average magnitude of the error. It's the square root of the average of the square differences between the prediction and actual observation. So a lot of people talk about what is the difference between prediction and forecasting. So prediction is basically till the time you have collected the data. If you are performing prediction on that data set, it is prediction. But if you want to perform prediction on the future data set, it's forecasting. So the only difference is till you have collected data. If you are predicting 5 steps beyond that point, then it will be called as forecasting. Now the forecasting algorithm we will be using is knife forecasting, moving average, machine learning algorithm like linear regression, SVM or support vector machine, LSTM, which is long and short term memory, is nothing but a special case of RNN, and Prophet and RMA. This is the example of knife forecasting on series. So in knife forecasting, we don't do much. We just take the data and then put it in the future. So what's happening? It's overfitting the curve. So if I want to write a code of knife forecasting, it's just appending the data one step beyond. And if I want to plot the knife, it's like this. It's following the same curve as your actual one. So it's your actual doing is just taking one step behind data and you are putting it in. Now we moving on to moving average series. So in moving average series, we do prediction in the we find the mean of all the data collected on that day and try to predict in the next window. Okay, so it's not just taking data to the previous day, but it is also trying to forecast it in the find the mean in the next window, in the future. Okay, so moving average. Now we can see here there's a window size that has been implemented. Okay, so now if we want to plot the series, how it will look like something distorted. So both naive and average are very basic algorithms, and the trend has been similar, but you can see it's just like little distorted curve, and there's a lot of error, like approximately 10,000 differences. So let's talk about time at train and valid set. It's important to take care of the validation set because of time series problem is tricky and we have to take into account the time component. One cannot directly use the train test split or k-fold validation since this will disrupt the pattern in the series. The validation set should be created considering the time date and time values. So we will be creating time and value set for our machine learning algorithms on forecasting of the data. So Now moving on to machine learning algorithm. So the first machine learning algorithm that comes in mind is linear regression. So what is linear regression? Linear regression is your fitting the line through maximum number of points. If this is the linear regression, the red line is trying to go through the maximum number of blue points here. So your theta is your parameter and x is your data. So how you train a linear regression model? You try to minimize the mean square error by tweaking your parameters and with your data set x and y. Training a model means setting its parameters so that your model fits the training set. All right. Now, taking the data sets date wise, now since we are getting into machine learning, we need to make training machine learning data set and valid machine learning data set, because we will be training in that train ML set, and we will be validating our algorithm in the valid ML data set. In linear regression, you can easily import a library called linear regression, and you can easily apply this training ML in the linear regression. So here, linear regression fit your machine learning date-wise and your training ML confirmed cases. While predicting linear regression, we again import linear regression dot predict for valid data sets on that days. So the graph look like this. You can see it is trying to pass through the maximum number of points, but we can still see there is a lot of difference of a number of confirmed cases from the actual one. Now, taking to the support vector machine. Now, support vector machine is also a classification between a positive and negative point, but it works in the hyperplane level. Now, what is a hyperplane is the question. To understand hyperplane, we have to go into a little bit of geometry. Now, what is a line? A line is a point with a direction. What is a plane? A plane is a line with a direction. So now what is a hyperplane? The hyperplane is a n-1 vector in n vector spaces. So the hyperplane is having n-1 vector directions. That is the first thing. So there are 3 steps for SVM. First step is you have to maximize the distance between your hyperplane and your support vector. Now, what is the support vector? The first point where it exists, the first data set point, the line crossing that is your support vector. So we have to maximize the distance between them. The second point is minimize the number of misclassification distances. So apply a slack variable and minimize the distance of misclassification. The third point is if the data is non-linear, so you can see that line cannot differentiate between positive and negative. Even plane cannot differentiate between positive and negative. But when we introduce a 3D mapping over here, if we map all the data in a 3D plot, we can easily differentiate between positive and negative. A simple example could be this. So you can see you cannot differentiate with the plane, but when you increase its planar ability in the 3D, you can easily differentiate the 2 points. So let's see if it improves the accuracy. First, we are trying to import mapping. So you will set all the parameters here in the param SVM using SVR. You will call grid search for describing your estimator and your cross validation. Now we are trying to fit the train ML days and confirm data sets. So you can see here, if you do not want to give some parameters by yourself, it will take its parameters defaults as well. Now if you're trying to predict, it's the best estimator. You can go to the valid ML database and then you can just predict. Now for the plots, so we can see a little bit of improvement. It is following the trend. The accuracy is also very well, but we are not sure that in future that this accuracy will sustain. So now I want to introduce RNN. So what I want to introduce RNN, that is recurrent neural network. We are now moving on to neural network. So the SVM that we perform, like that is like the basic one node of the neural network, and RNN is basically a sequential model of a special kind of networks. So if you have sentences and there are words in it, so if you want to understand the inferences of those words, you can use RNN. And yeah, so there's a lot of dependencies on the later data. So suppose there are two sentences: Bear Grylls runs a show and run away from the bear. So in those two, the bear word has two different meanings. One is animal, one is a person. So unless and until you finish the sentence and you reach to the full stop, you cannot understand that which bear is it pointing to. So RNN needs the whole whole sequence of your word to understand. It is largely dependent on the later data points or word coming up, and you can take any length of input and you can have any length of outputs here. RNN enable modeling time-dependent and sequential data tasks such as stock predictions, machine translation, text generation. However, RNN suffers from a problem called gradient descent, which hampers the learning of a long data sequences. The gradients carry information used in RNN parameters update, and when the gradient becomes smaller and smaller, the parameters updates becomes insignificant, which means there are no real learning done. So what is happening is, so these are the architecture of RNN. So you can see there's inputs at every cell, there's output at every cell, and the activation function is passing from one cell to another. So I told you about the problem. The this neural network architecture suffers from a problem of vanishing gradient. That means there is no loss left to back propagate and learn from the network. So there is not much learning happening in the initial cells. Okay. However, RNN suffers from the problem of vanishing gradient, which hampers learning of long data sequences. The gradient carry information used in the RNN parameter update, and when the gradient becomes smaller and smaller, the parameter updates become insignificant, which means there is no real learning done. All right. So to overcome vanishing gradient, we move to LSTM, or long short-term memory algorithm. In the LSTM network has three gates that update and control the cell states. These are the forget gate, input gate, and your output gate. The gates use hyperbolic, tangent, and sigmoid function to keep it activated. The forget gate controls what information in the cell state to forget given the new information that enter the network. The input gate control what new information will be encoded into the cell given the new information. So what is happening over here is there's a learning happening at every step, and there's a memorization memory which is forgetting some according to their importance, and it is keeping some and transferring it to the next cell. The output gate controls what information coded in the cell state is sent to the network as input in the following the time step. That is done via output vector. Okay. So it's pretty easy to code LSTM. You can import Keras model, Keras sequential model, and you can give 2 layers of LSTM, and you can give 2 layers of your activation function. You can pass on its parameters like optimizer, stochastic gradient descent. You can tell which optimizer you want. You can tell which matrix you want to know, and you can make a history model dot fit on the training data set. So this is how you fit the model or train the model on the data. So now if you want to predict, this is the output of the LSTM. Okay, you can see that it's following the trend very well, and it's kind of very close to the actual. Now we will get into model RMA. Model RMA fit or model dot fit prediction. You can just import a library called stats model RMA. From there, you can import ARIMA, and it occurs in log series. You can just fit the model, and then you can do the prediction in your valid set. Now, if we want to plot it, it will look something. So you can see we trained until this, and then we validated the set on this orange points, and the green points are your predictions. So we can see they're quite close, and the RMSE value is going to be quite low in the case of RMA. Now profit. The profit is been given by Facebook. So you can just import a library from FB profit, import profit, and then you can see the confirmed cases. You can make the data frame and zip it date wise, and the confirmed cases, and then you can take the date wise confirmed cases and your numbers, and then you can fit the profit, and then you can forecast. So it looks something like this. You can see it's quite close, and the black dots are profit prediction and the blue ones are the real ones. So now the comparison sheet. So we saw that moving average was about 42,000, and the linear regression was also didn't quite perform well, 35,000. SVM is about 22,000, profit 99,700, ARIMA is 4,000, and LSTMs is 10,000. So we have seen the cases of univariate models and in the confirmed cases of coronavirus. Now let's understand what is a multivariate model. The multivariate time series has more than one time dependent variable. Each variable depends not only on the paths values but also some dependencies on the other variables. So whenever we have different sets of variables and each are depending on each other, then we can say it's a multivariate model. And we will see how to solve a multivariate forecasting now. Okay. So in multivariate autoregression, in VNR model, each variable is a linear function of its past values, of itself and the past values of all the other variables. To explain this, it's better manner, I'm going to use this example. So suppose there are two time-dependent variables. So they are dependent on their constant values, their coefficients, and their errors. But these coefficients are not only dependent on this time model, but in its other time series values as well. So you can see how we can incorporate using vector autoregression model. Thank thank you everyone for joining me. In case you need the code, it is available on my GitHub account. You can follow me on Twitter, Pankaj Sonam. And if you have any queries, you can contact me directly through my email ID. Thank you so much. Thank you so much. It has been a pleasure.